Welcome, everyone. Thank you so much for joining us today. This is Basics of Blockchain with Python with Anuj Sharma, and I will now pass the session to Anuj.
Hello, everyone. How are you? My name is Anuj, and I'm from India. I'm a software developer and also working with different organizations as a coding instructor. And I think I'm not sharing my screen. So just share my screen. All right. Hope you can see my screen. Is it there? Just let me know.
Yes.
Yeah, great. So actually, I was preparing for this slide. So I asked my niece, who is 12 years old, and I asked her about like, have you heard of anything about blockchain? And she said like, what? What is blockchain? And then I said Bitcoin, and she answered, yeah, I have heard about the Bitcoin. And then I said like, okay, what about the crypto? And she said, yeah, I heard about the crypto. So we are going to learn about the underlying technology behind the Bitcoin, because Bitcoin is a use case of blockchain. All right. So moving on. So like there is this very famous thing, and we are going to have this pizza day, I think on 24th May. All right. We celebrate this Bitcoin pizza day on 24th, every 24th May. So there, in 2010, as you can see, like 10,000 Bitcoins for 2 pizzas, which roughly equals to $30. All right. And right now in 2020, you can see the estimated worth of those Bitcoins is this. So, okay. So, and I'm just going to say, just forget about the blockchain and especially about the Bitcoin, okay, for a moment, okay? And let's talk about like how we might have done things like 2000, maybe not 2000, 200 years ago. All right. So like, as you can see, like in the Bitcoin, we have the digital, sort of a digital currency, and we are just transferring this digital currency. And we talked about the crypto, but we really don't understand like what is exactly crypto and how it is helping us, how it is different from the paper currency. All right. And this was the mail sent by the developer that at that time in 2010 and he was asking for the pizza. All right. Okay, there is also one thing. Please do not read my slides. Okay. You will have the slides. I will share the link with you. Just like listen whatever I'm saying and just focus on the things, when I'm like underlined, when I'm like circling something and when I'm pointing something. So please don't read my slides. You will have the slides with you after the class. All right. So the first thing we will just like get a high level explanation, and I also say sort of a telescopic explanation of any topic. So as told you that like just go back 200 years ago. So back then, whenever we like, you must have heard about the ledgers. Okay, there we there we mention the particulars, the credit, debit, and the name of the person we are transferring to, and the time. Okay, sort of if you can imagine. So the problem was uh, uh, during that time was like, maybe let's say for example, um, so Alice sent, let's say, $10 to Mary. All right. And she wrote that she sent $10 to Mary, just for the record. All right. In her ledger. Okay. And just maybe and Mary says that she hasn't received $10. Okay. Maybe she's dishonest. Maybe uh, she did not write and she could not remember that she has received $10. So the problem, so there was like, uh, there were disputes about this in those days. All right. And we solved this problem by bringing, um, just one second, I'm just like, uh, bringing these, the central agency, okay, the central agency, the bank. Okay, so basically we will say that, all right, now Alice will like take help from this bank, and then Alice will transfer um whatever she wants to transfer to Mary. All right, so this central agency will authenticate Alice credentials. All right, and then bank will transfer the amount to Mary. Okay, and the bank will also authenticate Mary's all the credentials. Okay, and if there is any dispute, Alice can present the sort of any like authentication, any proof, okay, given by this bank. So bank can say, yes, we have transferred this amount to Mary. Okay, so okay, this is a current model. Okay, this is a current model, and we are using this. All right, and it is not just about the money. Okay, it could be about the ownership. Okay, whenever we are buying a car, so if I'm buying a car from Miss Stephanie, okay, and she's like transferring her ownership to me, then she will like, maybe she will sign a contract. All right, and maybe then we will go to the sort of a registrations registrar, and they will just authenticate our deal. Okay, so that will be a sort of a proof for me that I can show that this is my ownership and I own this thing. All right, so the problem with this central authority is that central authority, first of all, is slow. Okay, so maybe if I want to send money to someone in US or maybe in UK, then it will take a lot of time. Okay, and also the commission is huge. Okay, so whatever the medium I'm using, I need to pay some sort of commission. And maybe if I want to buy something from or Amazon.uk, then I will pay a lot of commission there. Okay, so to get rid of this thing, first of all, this process is slow, and we need to we need to give commission, and the commission is a lot. If you are buying a land, or if you're buying a car, then the commission is a lot. So to get rid of this thing, let's just assume that earlier Alice and Mary, they had two ledgers. Okay, so the problem was that Alice was writing her records, but Mary did not write her records on time. Okay, so it was creating a lot of confusion. Okay, so just imagine that if we have a ledger, only one ledger. Okay, and when Alice is writing something there, okay, magically it appears on Mary's ledger. Okay, so if Alice is writing $10 transfer to Mary, so it will be Mary will get uh, in her ledger. Okay, basically the ledger is same. Okay, but as I said, magically, all right, it is like she can see the record in her ledger. All right, so yeah, if you have any question or anything, just let me know about this thing. And just give me a moment. I'm just searching for the, yeah. Any question, please, about this ledger thing? If you are able to understand whatever I'm saying, that first of all, like 200 years ago, we had two ledgers, and after that, we have this central authority, and then we are trying to remove this central authority because first of all, it is slow, and it is purely centralized. And now we have sort of this future model where we have a single ledger. Just imagine, so whatever I'm writing there, whatever the record I'm updating there, it will be updated in Mary's magically. Okay, even if she is not writing there. If you are good with this, just let me know. Then I'll move forward. Just give me thumbs up. Okay, great. Oh, great. Nice. So just imagine that not just Alice and the Mary, okay? Let's say like all of us have this ledger, okay? Uh, like we distribute this ledger, okay? Peer to peer, okay? We all of us have this ledger, okay? And we can see this ledger. We have and we can read anything, whatever is whatever the data is there, okay? So first of all, no central authority. There is no central authority. Everyone has access to the record, okay? They can see, okay? And it is peer to peer, okay? So so whenever you are learning, whenever you are reading or learning anything about blockchain, you will see this word distributed peer to peer network, okay? And we will come to this distributed peer to peer network later after completing our high level explanation, because like we are right now, we are just seeing we are just having a telescopic view of blockchain, okay? So if you are able to understand this distributed peer-to-peer network, okay, we have this ledger and we have distributed to multiple people, okay, like this. And this is peer-to-peer. So whatever, so if this person is updating something, she will able to know the changes, okay? She will able to see the changes there, okay? And if she sees any sort of like mistake or anything, she can say, no, you have done this mistake, okay? So yeah. Okay, so moving on. But there is one thing, and you might ask, if this blockchain is actually shared across multiple computers, okay, or multiple people, even thousands of computer, okay, and they all have a copy of the same data, okay, sort of a block, what is to actually stop someone taking one of those earlier blocks and just change something in it, okay? They're trying to change some data there, okay? They're trying to um, like change the transaction data, or maybe the maybe the person's name or any data we are filling in there, okay? So, just faking a new transaction or deleting one or changing details of an old one, okay? Because like all of us have this copy, okay? So let's talk about this. Like, how can we stop this, okay? So before we like really like, before I tell you like what is, how to stop this, okay? What sort of mechanism we can apply in our like distributed peer-to-peer ledger, okay? Just keep in your mind, not think about the blockchain. Now we have a solution called distributed peer-to-peer ledger, okay? Now we have this problem, that um how can we make our this ledger, okay, more secure, okay? What are the things we can add in there so it is like tampered proof, nobody can change the data in there, okay? So this is one thing, like let's talk about this crispy hash brown, okay? So you have this ingredients, okay, and you have these ingredients and you have the step 1, step 2, step 3, step 4, and if you follow all these steps, okay, you will get this hash brown, okay? Sorry, I've changed my slide. Yeah. So if you follow all these steps, you will get your hash brown. But if you do any change in the ingredient, okay, if you change anything in the ingredient, you will get something else, okay? If you agree with me, just like give me a thumbs up. What I'm saying, like we have this ingredients, okay, step 1, step 2, step 3, step 4. And if I change any ingredient, I will get something else. Okay, so please remember this. If I change anything, I will get a new thing. Okay, it cannot be the same thing. And also one more thing, which is um, this, that yeah, I cannot go back. Okay, means to say, like, I cannot get back. I cannot get my egg, okay, back from this hash brown. Okay, because like when I was cooking this, when I was when I was preparing this, a lot of things. So I was doing like a lot of things, and during the preparation, a lot of the things, like due to the process, I cannot go back. There is no way that from this crispy hash brown, I can get my ingredients back. I can get my egg back or the cup oil for frying. Okay, I cannot get these ingredients. Okay, so two things. Okay, third is if I change anything. Okay, if I change anything, just one second. If I change anything or if I add anything in there, good, immutable, I'll come to this. If we change anything, let's say for example, like salt and pepper. Okay, you can see salt and pepper to taste. Okay, maybe if I add like more pepper, then um we were like told to. Okay, and instead of salt, I'm maybe I'm like adding black salt, maybe. Okay, I'll get different taste. Okay, so if I am doing a like single or like very small change, okay, I will see that change in my result. Okay, so again I will say I have these ingredients. Okay, and after following these steps, I'm getting this result, crispy hash brown. I cannot go back. Please remember these things. I cannot go back. And if I do any changes in this ingredient, I won't be able to get this result. Okay, and there is also one thing, which is um, which is to so let me recall. All purpose. Okay, okay, no problem. So yeah, okay, let's go. All right, so you can just imagine the spreadsheet. Okay, and when or maybe you can think this like a ledger. Okay, now we are updating our ledger with a hash. Okay, so we have our timestamp, we have the data, and the previous hash and the hash. Okay, so the columns you are seeing here, it is not like you need to like create data, something like that. Okay, you can create credit and debit as well. Okay, so it is not exactly the same thing, but yeah, a few things are so first of all, the timestamp, previous hash, and the hash. Okay, so okay. So what do we do? So okay, what is this previous hash and hash? Okay, let's talk about the hash. So I told you, so we are getting this result A3, A345, F2G THTJ. Okay, something something doesn't mean anything, but I'm generating these hash, all right, with two ingredients. Okay, right now I'll mention more ingredients later, but we right now we have two ingredients, which is timestamp and the data. Okay, so we are cooking up timestamp and data, and we are getting this hash. Okay, so just imagine like there is some sort of like some source, there are like some steps. Okay, and I'm getting this like weird thing, A345 FT whatever. Okay, so I'm generating this hash. Okay, and this is a previous hash. Okay, just imagine this previous hash is coming from another block. all right, or another row. Okay, so row by row, page by page, okay, block by block, all right, that is the same thing. So as you can see, we have rows here. So we have this timestamp and data. We are doing something with it and we are generating this code. Okay, it could be anything. Okay, really, okay, it could be anything. So I have this timestamp and I have this data, and I get this previous hash from another block, from previous block, and this is the hash. Okay, and I'm getting this hash from this timestamp and data. So this is my hash. Now, when I'm updating or when I'm adding, all right, another row, okay, I am referencing this hash, okay, here, okay. So I'm creating a sort of a chain, okay. With these rows, I'm creating a sort of a chain. So you can see previous hashes here. Then I'm adding another row, data, and then you can see the hash of this row is now the previous hash of this row, and this row now has this hash again, and now you can see that we are referencing this. Okay, now what and you would say like, okay, what is so special about it? Okay, all right, maybe, okay, someone like trying to do something like maybe illegal or mischievous thing. So he comes here and he tries to change from $30 to maybe $35. Okay, $35. Or just I'll take like few pauses to cough. Yeah. So if I change anything from data, which is like credited $30, maybe I say $35 there. All right. So what would happen? Okay. Basically, I told you, if I'm changing any ingredient, I will get something else. I will not get this particular thing. Okay. I will get this hash if the timestamp is this, and if the data is this, okay, then only I'll get this hash. Okay, ingredient should be same, okay, exactly same. And if I do a little bit of change, I'll get another hash. Okay, so what would happen? Just imagine. Okay, so if I'm doing something, let's say I'm able to change this, okay, and I'm getting another hash, something, okay, just imagine. Um, so basically, if I'm changing this hash, so okay, this hash has been changed, and I changed this row. Now, this previous hash, the previous hash is still the same thing, A345F2. Okay, I haven't changed this thing. Okay, then I have like basically broke the chain. Okay, and all of us will able to know that something is going on. Someone is trying to change this thing. Okay, and there is a like broken chain, and people will get alert, and then they will able to know that where the data is was like changed. All right, so timestamp data, and the basically like I'll basically like timestamp data in previous hash. We do something with this, and then we generate a hash. Okay, so yeah, so this hash and this hash, okay, they are very useful to create a link um within these rows. Okay, or you can just imagine blocks. Okay, we are just creating a chain among these blocks, okay, using this hash, or maybe you can say crypto. Okay, and maybe like just imagine, okay, data, I'm able to change the data, but if I'm updating anything, I will get another timestamp. Okay, timestamp will be changed automatically. Okay, so they would able to know that obviously this block was here. Okay, And after this, on 24th December, this block was updated on 25th, on 26th, and maybe on like somewhere around 28 December, I'm able to change something here. Okay, so whatever I'm doing there, it will be reflected to the peers. Okay, and they will be able to notify that something is wrong there. Okay, we will talk about this in more detail later, but if you have any question, just let me know in the chat. If you are able to understand like how I'm generating hash, I can give you like one example. I can give you one example where you can just imagine that you have created something like this, um, sort of Alice, and you said, okay, where we have A, I will create a code. Okay, let's say if it is an A, then you will say, okay, 5. For L, it is maybe 10, and for the I, it is something and something something. Okay, basically you are creating like sort of an encoding for the name. Okay, from there you are creating a hash. Okay. Please ask anything, any question. Okay, so I can explain more about the hash. And if you're comfortable with the hash, let me know in the chat. Okay. Good question. So let's say, Aditi, you are creating your own blockchain. Okay. A lot of companies nowadays, they are creating their own blockchain. Okay. Like Ethereum and all of them, like AWS, Amazon, IBM, they are creating their own sort of blockchain technology. So if you are creating your own blockchain technology, of course, you can create your own hash formula. Okay. The famous one, Bitcoin uses SHA-256. That hash formula was created by the NSA. All right, so they are using that SHA-256. We will discuss that. So yeah, you can create your own formula. If you do not have any question, just give me a thumbs up. That would be a great feedback. Exactly. Yeah. All right. Moving on. So we are done with this. So before moving on, all right, we like studied like few things. First of all, distributed ledger. Okay, basically distributing the ledger, and peer to peer. It is available to like all of us, and also the hash. Okay, so okay, so if you're good with this, then let's get more technical. Okay. Now I think we are more comfortable in like reading this definition. Okay, although it still has some fancy technical terms. Okay, so the reason that has enabled the success of Bitcoin and almost all the cryptocurrencies that have followed is fundamentally a security and the trust mechanism. Okay, it is called blockchain. Okay, so we are going to learn about blockchain, the underlying technology behind Bitcoin. Okay. All right, so the question is like, who thought it first? Can you name, do you know anyone? You must have heard about Satoshi, that guy. But it was way back actually. Okay, I'll share the link. It was way back. It was uh, like this thought about the blockchain and all these things. Um, all these things came from this how to timestamp a digital document. Okay, and this paper was written by Stuart Harbour and W. Scott Stonetta. All right, I'll share the link. This is the link. If you click on the link, you will get to the paper. Okay, and you can print it and you can read it. Okay, it is a very easy read. All right, so the thing with this, let me give you like one more, like whatever the digital data we have. Okay, so for example, if like any singer, okay, wants to publish their album, okay, so generally they go to Apple Music or generally they go to Spotify, okay, and they have their what do you call that, sort of a royalty, or maybe I'm skipping it, it is called sort of a like uh, like with which they can claim that it is this album was published by them. Okay, it is called DCIM. I'm unable to recall. If you can help me, it is called digital rights. Sorry, it is digital rights. Okay, so just imagine, obviously all these singers, all these like artists, they are paying a lot of like money to the Apple Music, Spotify, and like many like this. Okay, so if they are saving the data in the like the data blockchain, okay, they wouldn't have to do that. Okay, so yeah. All right, so now we can just like imagine this block. Okay, so in this block, typically we have the data could be anything really. Data could be anything really. Okay, it could be a currency. Okay, it could be and maybe ownership. Okay, it could be like your health data, it could be your like any sort of maybe social security number. Okay, we can save their social security number, and we will also have timestamp, we will also have previous hash and the hash. Okay, this is sort of a typical and typical like block. Okay, and this fingerprint signifies that this is a hash. Okay, and basically hash means like we are putting our fingerprint, means because like we have like unique fingerprints. Okay, so that's why the fingerprint is there. So I won't go and I won't recite all these things. Okay, now I think you are comfortable with hash. Okay, as long as you can explain hash and the previous hash in your own words, you are good to go. Okay, later on later on you can come to this page and you can read about the hash. You can read this like fancy definition about hash and the previous hash. All right, and the timestamp. So generally our blockchain looks like this. Okay, and I showed you like the Google that Google shit, like row 1, row 2, row 3, row 4, row by row. Okay, this is like block by block. All right, so block by block, and they are connected with this sort of a chain. Okay, and I told you this chain, like we're able to create this chain using hash and the previous hash. Okay, so there, the current ID and previous ID is it's basically here I'm saying hash and previous hash, current hash and the previous hash. Okay, no need to be confused with this. And obviously they are in they are in like chronological order. Okay, because obviously as you have seen that they are connected with the previous hash, and if I'm changing something there, I'm basically like breaking the chain. Okay, and that is not, obviously that is not chronological, and I can also I cannot create another row. Okay, after the second row. Okay, I cannot do that. Okay, and maybe like if you are familiar with the databases. Okay, I'm not sure about uh your the background. Okay, you're coming from, so maybe if you're like comfortable with the Google sheet, so you can imagine the Google sheet, or maybe you can if you are comfortable with the SQL or SQL, something like that, so there you can imagine that there we also have rows. Okay, so in the Google sheet we can just say insert another row. Okay, and we can add another row, and there I can do something, I can update the data there. But in the blockchain it is not possible. Okay, I cannot add something in between. Okay, and that is why it is called append only. Like I can add block at the end. Okay, I cannot add any block here. Okay, so yeah, so the first thing you should know, if you're comfortable with this concept, that I cannot create I cannot put any block, okay, here. And if I'm changing any data of this block, basically I'm breaking this chain. Okay, so if you are comfortable with this this thing, just let me know. And if you are unable to do so, then also please let me know if you have any question. All right, great. Okay, moving on. So basically, like if we break blockchain, so block is an individual transaction or a piece of data we are storing. In chain, list that holds all the blocks inside the blockchain. Okay, so yeah, that's the thing with the blockchain. All right. So when I'm here, okay, I think you are comfortable with the distributed peer-to-peer network. Okay, and you're also comfortable with the hash cryptography. Okay, you are comfortable with these two things. Okay, let's come to the immutable ledger. Okay, immutable ledger means to say I cannot add it. Okay, my ledger. Okay, so if I'm writing like ledger, okay, on a piece of paper, okay, obviously I can try to change something. Okay, I can try to add it something there. Okay, because like there is no previous hash. Okay, right now previous hash and hash is coming from sort of a algorithm we have created. Okay, so we are getting this previous hash and the hash automatically, and we can't do much about it. We cannot change that. So immutable ledger. Okay, what is consensus protocol? Okay, consensus protocol basically like whenever we are adding any block, okay, at the end of our blockchain, okay, whenever we are adding, because like as I told you, we cannot edit the data. Okay, and we cannot add any other block. Okay, any other block. Okay, in the blockchain. So but we can add the block at the end of the blockchain. Okay, so okay, so whenever someone is adding block at the end of the blockchain, okay, there is a thing called consensus protocol. Okay, maybe I told you that I cannot change. Let me just go back to the slides. This one, yeah. Obviously it is not like easier for me to edit something here. Okay, because like basically I'm breaking this chain. Okay, but I can just come here and I can add another blockchain. Okay, and then I can fill some like mischievous data there. Okay, which is not correct. Okay, so I'm adding some data here and some data here. Then the previous hash. Okay, for somehow, okay, I'm able to get the previous hash. Okay, so if I'm able to get this previous hash, okay, then I can like very easily update this um, timestamp and data without any problem. Okay, without any problem I can update the timestamp will come automatically. I need to change the data. I need to update the data, and I will get the previous hash. Okay, I'm able to crack the previous hash. Okay, and I'll generate the new hash. Okay, very good question. Yeah, when I learned about this, like that was my same thing. Like the blockchain is linked list with immutable ledger and consensus protocol. Very nice, great. So like all of you, if you are comfortable with the linked list, yeah, that is absolutely, the concept is quite similar to that. So if I'm able to do that, I can like, boom, I can change something. Okay. So, okay, but to like, but to create like temper proof, okay, structure, we have something called proof of work. Okay. So proof of work says, okay, whenever we are adding any, whenever we are adding any data, okay, in there, whenever we are adding any data in there, okay, um we will have this consensus protocol. Okay, because like just imagine that all these, like just imagine that I have 12 blocks. Okay, and okay, you can see they're like 1 2 3 4 1 2 3 4 1 2 3 4. Okay, and I came here, okay, and I added another block. Okay, I did not add any block here. I did not add any block here because like obviously I'm able to change like in a one machine. Okay, so, and I'm able to change here. Okay, then all of them, okay, they will get sort of activated, and they will check the data. Okay, if they see any sort of like illegal activity, any suspicious activity, they will say no. Okay, it is incorrect. Okay, and they will kick me out. But if 51% of them says that no, we this data is correct. Okay, there is no problem with this data. Okay, I will able to get my block here. Okay, but there is more in the proof of work, not just this consensus protocol. There is also one thing which is like sort of a time. Okay, I can do it if I'm able, I can do it. Like I need to like invest like at least I think 10 minutes. Okay, to do this. Okay, so there is a like sort of a time constraint to append any blockchain there. Okay, that's why blockchain is that is a one, because a lot of people say, okay, then if blockchain is like such like is so like if it has so many like advantages, then we want use SQL. Okay, and then we want use no SQL. Okay, but there is like one huge disadvantage, which is this blockchain is slow. Okay, because if I'm adding any sort of data, it will take a lot of time to reflect that data in a blockchain. Okay, because of the security. Okay, but as you must have seen in SQL, or maybe if you are updating any data in the in like in your spreadsheets, okay, it is very easy peasy, and you can just you can add it, you can add, you can update, you can insert any data. Okay, like maybe 1,000 rows. Okay, way faster than blockchain. Okay. So now I want to go through this. You already know what is hashing. Okay. So just like Alice has sort of her unique fingerprint. Okay. We are giving unique ID to our documents. Okay. Like this to our data. Okay. And Bitcoin follows SHA 256. And this algo is created by NSA. Okay. All right. So this image, this picture like tells you that if I'm trying to alter any data, okay, of an existing block, then I'll get an alert. Okay, and I won't be able to do that. It is not possible. And it is for the distributed P2P peer-to-peer network. Okay, basically you can just imagine that we have these computer and all of them share this distributed ledger. Okay, and if I'm trying to add anything in there, I won't be able to do that without consensus protocol. And I need at least 51% of them to say yes. Okay, um, we do not have any problem with this block, okay, then I will able to add this block here, okay. So yeah, there is also one thing which I want to discuss. Obviously, there is a like one block, the one Genesis block, okay. So that Genesis block has a hard-coded previous hash value, okay. So yeah, though it doesn't have any like link to the previous hash, but it does have a previous hash, okay. All right, like what is the difference between blockchain and the traditional databases, okay? Because like after all, we are storing the data, okay? So in there, um, first of all, in blockchain, it is virtually impossible for someone to change the data without breaking the chain, okay? But in the traditional databases, as long as you are able to crack the code, okay, of the administrator of that uh, database, okay, and when you are in the database, you can do anything. You can delete the database, okay, and you can edit anything there, okay, and there is no trace, okay. If you have done anything there, there is no trace. You cannot like find, okay, what has been changed, what are the changes, okay, who has changed it. There is no track, there is no, and there is also a like central authority, okay, someone is like keeping our data, okay. So in the blockchain, we are also removing the central authority. So blockchain is like data can be only read or added to the blockchain, okay. But in the traditional databases, we can create and we can read, update, and the delete, okay. So we can follow these operations, okay. So there is a difference between blockchain and the traditional databases. There are more use cases of blockchain, okay. So we can use blockchain. We have these use cases of blockchain. We can use, obviously we are using it in a digital currency, and we can use it for the intellectual property, and we can use it for the voting, and we can use it for the um, public records, okay. So yeah, okay, that's it. Like if you have any question, then please let me know, okay. And please like tell me like which programming language do you use, or maybe you are learning, or maybe you want to learn, okay. Because we are going to use Python to give you a like quick demo how to create this, how to create the blockchain, and how to translate the whole concept, okay, using using a programming language, and we are using Python. So please let me know what programming language do you use, or maybe you are learning, or maybe you want to learn. Great. Okay. So you are using Python. All right. Great. Python. Oh my. Okay, great. Then you are going to enjoy a lot. So I'm gonna unshare my screen, and then I will share my screen again to show you my VS Code. Okay, great. That's great. So I'm sharing my screen. Where is my VS Code? Okay. Just let me know if you're able to see my VS Code.
Yes.
Great. All right, so I'm in my VS Code, and I'll create a folder first quickly. All right, so first of all, like I'll create a file block.py. Okay. So in here, we are going to create class. Okay. And we will mention few things for the block. Okay. So just wait a minute. I'm just all right. So the first thing I'll do here is maybe yeah, okay. Sorry. So first of all, because we will create a timestamp, that's why I'm calling timestamp. All right. And I'm also calling a module, and this module is already there in our in Python. So you don't need to do pip install and all those things and import. And this is how I'm importing this module. And then what I will do, I will create a block. So this is the way we will do it in Python. Def, not def, I'll create a class. So class, and the name of the class is block, like this. And then I will initialize the variables. And in there, I expect to have timestamp. Maybe I'll call the transaction, not the transactions, and the previous hash, like this. Okay. So the thing is, like, the first thing is timestamp. The second is transaction, and then I'm expecting previous hash. All right. Then I'm expecting, okay, we haven't, then we are calling the hash, and then we are calculating the hash. And then great. All right. So these are the things we need here. Okay. And if you have created a linked list, then this is a way we create the linked list. All right. So the first thing we have is the timestamp, and I'm storing the time, the current time here. Then the transactions, like this, and the previous hash in a variable called previous hash. And we haven't talked about this. Okay. And I'm going to use this here, which is this self and is equals to 0. Okay. Now you may ask, like, what is this? Okay. This is basically number used only once. Okay. And we have this thing. Okay. I won't go in depth. Okay. We have this number. Okay. So whenever we want to change anything, okay, not in the blockchain, but we use it in the proof of work. Okay. So you have this thing, and you can change the previous hash of something, okay, using this number only used once. Okay. And all the miners are basically just playing with this number. They are trying to get the right number. Okay. So if they are able to get this, if they are able to get this correct knowns, they will able to get the previous hash, and then they can add another block after that, after like at the end of our blockchain. Okay. So this is the self knowns. Okay. Now I will do this self hash equals to self dot generate and hash. So we are generating hash, we are generating previous hash, we are generating transaction, and the timestamp. All right. So we have created this block. Okay. Now let me show you one more thing. Okay. It will help you to understand the hash. Okay. How does hash works? Okay. So I'll just come here, hash.py. So in here, so if I just like call from hash hash live import sha 256, and then I say text equals to text equals to, and I say hello to the code. I'm sorry if there is any typo. Hash result equals to, all right. So I'm just SHA 256 text dot and code here like this. And then I will print it, okay? And you can see that I have created this hash, okay? So even if I change anything, okay? Even if I change anything here, okay? Even if I put dot, okay? Please remember this thing. And if I run it again, you can see there is a huge change in this in here in the hash, okay? So let's come back here. So after creating this like a basic thing, okay, so we are creating a transaction timestamp and all this thing, okay. Then we will add like few methods here, okay, in the block. So the first method I will add here is to print the block, okay. So I will say print block, and I am expecting all the variables I have described above. So I just need to write self. All right. Then I will say print. All right. And after the print, I will say timestamp and the transaction format. And then I will print the not the previous hash. I want the current hash. Okay. So I'm gonna write the current hash here. Current hash like this. And okay, so after creating this, so we are creating this print block. So we are, if you are calling any block, okay, we will able to see that we will able to see the time and the transaction, the current hash of that block. Okay, so okay, now we'll create another this generate hash, okay, method. And in this, I'm gonna call like block contents equals to just maybe I can do this one sec. It will be easier for you to. Okay, so these are the contents in the block. Okay, so these are my ingredients. Okay, just remember these are my ingredients: timestamp, transaction, data, previous hash, and this number used only once. Okay. Then I will create my block hash like this. Okay, so basically like what I'm doing here is block contents dot encode. Okay, so after like adding these things, I'm encoding this block content dot encode just like I have done here. Okay, this was my text, and here I've encoded this thing, and here I've printed it. So in the same way, this is my data. Okay, and here I'm storing the hash in this variable called block hash, and I will return this block hash dot hex digest. Okay, so I'll get the hexadecimal numbers. Okay, Okay, so after creating this block, so we have created these, this sort of things we are going to put in the block. Okay, then we are printing in the block, then we are generating the hash. Okay, hope you are comfortable with this. Now we will create another, now we will create blockchain. Okay, blockchain model, blockchain.py. So in the blockchain.py, um, we need to create a class for the blockchain. Okay, so just imagine what do we need to have in our blockchain. Okay, so first of all, in the blockchain, the first thing we need to have is block. Okay, so I'll call my block and import block. Okay, so I'm importing this class here. Then I'll create a class blockchain. Okay, like this, blockchain, like this here. Okay, and then I will create, then I will initialize the variables, and it means initialization. I'm initializing the variable self, and here we go. So here I will say self dot chain. So I'm creating a list. Okay, and in the list I'll keep all the blocks. Okay, and self dot current transactions, here I will keep the current transactions, or maybe not, I will not do this. Okay, maybe I will say self dot all transactions. Okay, and here the blockchain should have this, like the first genesis block. Okay. All right, now moving on. Okay, so obviously the first thing we will have is to create a genesis block. Okay, and in the genesis block we will have this transaction, and this is my dictionary. Here I'll keep the genesis, here I'll keep the transaction. Okay, so it will be like sender and the receiver and the name of the receiver and the transaction and the amount transferred there. And genesis should have a previous hash. Okay, so here I'm adding previous hash equals to let's say 0. Okay, so here I'm saying previous hash is equals to 0. One sec, it should be hash. Okay, previous hash. Okay, now I will do something to append all these things. So self dot chain append. Okay, this is the way we add things in our list. Okay, append is a method. Okay, and those if you are doing JavaScript or something like that, you must have heard about the array. Okay, an array. So just like that, we have list. So in the JavaScript, I think you use push. Okay, to add something in the list. Okay, so in here I'm using append. In Python we use append, and the block transactions. Okay, so here I will write the previous hash. So I'm just gonna copy this and previous hash, so it will have two things, transaction and the previous hash. Okay, so I'll call this block. Okay, so basically, like, I'm calling this block. Okay, and transaction the previous hash will come from here, transaction on the previous hash. Okay. Okay, so after creating this genesis block, okay, generating hash and all these things, what do we need to add? Okay, so we need to create another thing, which is like, because like we created the blockchain, but we need to get the output. Okay, and how do we get the output in the Python? uh the general thing is like, if I want the output in the terminal, then I will use print statement. Then this is the way I will do it. So self. Okay, so I'm calling this, and then I will run a loop. Okay, why? Because like I want to call all these blocks one by one. So if I want to do it something like repetitively, then obviously I'll use loop. Okay, so for, okay, maybe I in range. Okay, and this range will come from the length. Okay, and self dot chain self dot chain for I in self dot chain, then the colon. Okay, and after this I'm gonna have current block equals to self chain. Okay, like this, self dot chain equals to the current block. Okay, and after this print, I'm gonna print this. Okay, and this is the way I will print my block. Okay, so the current, I'm getting the current block here, then I will print it. Okay, so let's just assume there are three blocks in my blockchain. So this loop will run 3 times and I'll get this then every time. So if it is like, if there are like 3 blocks, okay, so I'll get like self dot chain 0. Okay, then I'll get another block and then I'll print it like this here. Okay, so moving on to the next line. Then current block dot print block. Okay, I'm calling a method called print block, and this print block method is available there. Okay, here. Okay, it's available here. Okay, so print block, self for I, range, self dot chain, and all these things. So okay, so one thing we need to add in our blockchain, just try to imagine what are the methods we need to add in here. Okay, or maybe not in terms of the methods, you can think about the features. Okay, so in our blockchain we have genesis block and we have print blocks. After that, I think we need to add another method. Okay, which is add block. Okay, so blockchain should have a method to add a block. Okay, so after this self dot transaction. Okay, so the previous hash and previous hash equals to self dot chain. Okay, -1 has, and it's a hash, maybe if I'm not done any mistake. Okay, so new block equals to block transaction previous hash. Okay, and then self dot chain dot append, then I am adding this block, okay, in my chain. Okay, this new block here in my chain. Okay. Okay, so we are done with this. Now we need to do something to what do you call that, to maintain the integrity of the blockchain. Okay, sort of security. Okay, I told you that there I talked about one thing which is called proof of work. Okay, so we'll do something in to like which will validate the chain. Okay, if I'm adding a block. Okay, is is the block really the like genuine, or is there anything wrong in there? Okay, so we will check if there's something wrong in there or not. Okay, so the first thing is I'm gonna call validate. Okay, so validate chain works like this. Okay, so for I in range, so validating chain it has all the blocks. Okay, so if current hash is not equals to the current dot generate hash, okay, return false. Okay, and if current dot previous hash is not equals to the previous hash, then do this. Okay, maybe we can do something else with this. Okay, maybe we can say instead of returning false, we can do something else. We can say print, and we can say the current hash of the block does not equal the hash of the block. Okay, so if it is not like that, then I'll get this. And in here, I will say this print, and I'll say the previous hash of the current block is not equals to the previous. One sec. All right. Okay, so after that, I'll say maybe I should add one more thing, return false, because when I'm updating and also one thing, like don't expect that you would able to like understand everything, because of the times constrained. Okay, I can go in depth. We are already running out of time, so that's why. Okay, so return true. Okay, so I'm basically like adding this validate chain. This method will validate when I'm adding any block. Okay, at the end, then it will validate that if the previous hash is um, equal to the current generate hash or not. Okay, so now after doing this, okay, we will add another layer of security, which is proof of work. Okay, so proof of work works like this. Okay, so proof equals to block dot generate hash. So what is this? Basically, like I'm generating hash. Okay, so while proof, and this is the level of the difficulty I'm adding. Okay, and then this is the way I will add like each block one by one. Okay, so when I'm done with this, I will say that successfully mined block or successfully added block, and if not, then I will write something else. Okay, so this is the way like I will add this method proof of work here. Okay, so yeah. I'm sorry. Is there any question? Okay, so as you must have seen that we have this method here, generate hash. How did hash originate? Means to say like sort of like you are asking in terms of history, when did it came first? Sorry, I'm not able to. Um, okay, what is difficulty? So difficult in terms of the difficulty, you can just say like I'm adding uh, I'm adding a sort of a time that you need to complete this, um, or you can just imagine it is an extra layer of security. Okay, so I'm adding like 2, 3, 4, then I'm like increasing the layer of security there. That's the thing with the difficulty. Okay, in Bitcoin we have this sort of time like 10 minutes. You need to spend at least this amount of time. Okay, if you want to add something there. So yeah, that is the difficulty level. Any question? So I'll share the link and you can read about the SHA 256. I told you it is created by it is like actually it is written by NSA. Okay, of USA. So you can just like go and read about this whole thing, how it came. All right. Okay, so moving on. So yeah, we didn't go in depth about this. What is known? It is no number used only once. Okay, just imagine. Okay, whenever you want to log in, okay, whenever you want to log in to your Gmail account or maybe something, you get this OTP. Okay, you get this OTP. Okay, and you can use it like only once, and then you will you enter your credentials, and there you go. Okay, in the same way, we add some sort of a like this knowns. Okay, there this helps the miners to know the like to know the previous hash of a number. Okay, so if they are able to track so if you are a miner, let's say, okay, then you will say like what is the hash of my of the previous block. Okay, if you know the previous hash, okay, or the hash of the last block, then you can add the block, then you can add another block there. Okay, then you are a miner, and then they will like sort of a um, then you can add another block there. Okay, that is the thing. Okay, so how can you do that? Okay, how can you just like um get the track of the hash, or how can you guess? Okay, how can you guess the this hash? Okay, so all the miners, and you must have seen in the if you open your if you open the YouTube and you type like miners rig on the Bitcoin rig, so they have all this machine, and all these machines are basically trying to get this um this number, which is number used only once. Okay, they're trying to get this number. Okay, and if they are able to get this number, and if it is correct, they're able to get the hash, then they can add another block there. Okay, and then yeah. So let me run it. Let me run it once. One sec. So if I want to run it, okay, so I have the same thing here. If I want to run it, and in this, I have few blocks. Okay, so this is my file, and in this, I have this dictionary, and in the dictionary, I have these are my transactions. Okay, so my transaction says the sender name, the receiver name, and the amount. Okay, as I told you, like typical transactional block, and then I'm like storing I'm like calling this class. Okay, and then here you can see I'm using the method add block, add block, add block. I'm calling these block and I'm adding these blocks in the blockchain. Okay, so let's run this. Let's run this block. Um, I'm resharing my screen. I'm not sure if you're able to because I'm talking about some. So here I am. Okay, so nothing different from there. Okay, we still have two files like block and blockchain.py. Okay, I have another new file which is like make.py. Okay, and I'm calling this class blockchain, and in the blockchain I'm trying to get these blocks. Okay, they are in my blockchain. Okay, so I'm calling this method add block, add block, add block, and these are my methods. Okay, so okay, so let's run it. Python and make.py. Okay, so you will see. Okay, not so intuitive because it's in terminal, so please pay attention here. So block 0, and I'm getting the timestamp transaction current hash, and the previous hash is this. Okay, so yeah, so this is my Genesis block. Okay, this is my Genesis block. There is no transaction. Okay, now this is my first block. Okay, so in this first block, I have this data, transaction current hash and the previous hash, and in the second one, the same thing. Okay, and in the third one, there is the same thing. Okay, so let me remove this, and okay, let me see. Okay, because like I'm trying to add a fake transaction. Okay, so how do I know like if it is a fake transaction? Okay, because like the receiver, so here I'm saying the receivers are like two. Okay, two people like these. Okay, and the amount is 125. Maybe Mary does not have 125. Okay, so okay, because she had already sent, Mary already sent Chloe 125. Okay, so she does not have more of 125. So what I will do, I will just remove this and CLS, and now you can see something is no, one sec, I need to validate. Okay, I was trying to add this, but I was not validating it. Okay, so now I will validate this chain. Okay, if this chain is so yeah, so it says at the end that the current hash of the block does not equal to the generated hash of the block. So that's why that block cannot be added. And there you can see we still have only three blocks, block 1, block 2, block 3. Okay, there is no block 4. Okay, though I was trying to add this fake transaction, but it was rejected by this by our blockchain. Okay, all right, so okay, so if you have any question, please let me know. Okay, I am done with my presentation. Thanks, Aditi, for joining. Thanks.